Welcome back to Data Analysis 1, the beginner's class for data analytics and data science. The last time, actually, I planned to continue the class with the next chapter, but then I realized for now that we should also get into R a little bit more, a little bit deeper, because R is not Python, but it's actually, for our case, it's even more simplified than Python. So, again, what was that? What were the topics which we just had before so far? So, I think the first time, what is about data science? What is it? Then we talked about the types of data. So structured, unstructured data, quantitative versus qualitative data, and the 4 levels. So what was that? The 4 levels: the nominal level, right? The ordinal level, the interval level, and the ratio level. And in chapter 3, we were talking about the following. So again, a little bit more about data science, and then the 5 steps. So the essential 5 steps in data science. Ask an interesting question or more interesting questions, then obtaining, so how to obtain the data privately, publicly, how to download, where could you find those things you have to find out. Then how to explore the data set. This is exactly where indeed we had 2 data sets to work with. We also filtered one, right? And then modeling the data and communicating and visualizing the results. So 2 examples we had. Data frame or data set 1 was about Yelp. So the data set, public data set that is available, and it's a restaurant review. And then the other one is the Titanic. The people who actually were on Titanic when it sank. So in 1912. So who were deceased at the time, so who died and who survived, etc., etc., ages, and so forth and so forth. And then we dealt with the first issue where some of the cells are not filled in, so they are NA, right? And we had the chance to fill them up, all of them, by the average age of the travelers. All right, so that's what we were doing. And from here, the next topic, what we do, is some basics about R. So here we go. And let's see what are these basics. Okay, you see them here, variables, how to set them, how to list them, how to delete them, then how to create vectors. Computing basic statistics, basic statistics we involve here, actually kind of review again, and then creating sequences, then vectors, so how to compare them, comparing vectors, selecting vector elements, and then performing vector arithmetics. And then we talk about getting operator precedence, right? So precedence, operator precedence, hierarchy in the operator levels, and then typing less and accomplish more, and creating a pipeline of function calls, and avoiding some common mistakes. So this is under this little bit more basics. And then we finish this time. So let's jump in and let's start with R. For that, you need RStudio. You see it here. I have already downloaded it, and also installed it. So please do it if you haven't done it yet. Okay, so the basics in programming we know. We always do some kind of printing. So print, write, and hello world. This should work also here. You see that? But let's take another value, pi. Oh, we got the pi without anything else. Then square root. We don't have to explain r what is square root. We just have it. Okay, so print, you could use also print sqrt and let's say 9, right? And you see it's 3, right? And so forth and so forth. Now you can use the print, but you don't need to use the print. You see that? So the beauty of print is that it knows how to format any R value for printing, including structured values such as matrices and lists. So let's use the matrix this time. Print. Oops. Print and matrix, and now we have to tell, you see that now we have to tell what are the values and the number of rows and number of columns. So C 1 2 3 4 4, and the number of columns are 2, and number of rows are also 2, so 2 2, so number of rows, number of columns. And let's run it. And you see we got 1 2 3 4 in the form of a matrix. And then the next one is a list. Print. We can actually do it here as well. You see that? So print and then list A, B, and C, and let's see if now the program will shout at us or not. No, it doesn't. You see that? It takes in this way also the quote marks, and we see that the list elements are A, and the second element is B, and the third element is C. One more thing you realize here, we never started with the index number 0 like you would start in any other programming language. Now that's the point. Okay, now you need not write special printing logic even for complicated data structures. But what you can do additionally is print. Okay, this we will see. The print function has a significant limitation. However, it prints only one object at one time. This we have to know. Trying to print multiple items gives this mind numbering error. So here it doesn't work like in Python. As you remember, we have done it in a different way. So this 0 occurs at, and now we'd like to get this in number. So 2 times pi radians, and you see I tried to run it and we got a invalid quote argument. The only way to print multiple items is to print them at a time which probably isn't what you want. So print the 0 occurs at, so like this, and then print 2 times pi. Oops, this is now number, and then print radians. So I select all the 3 lines, and you see now, but this is not what you want to do. What you want to do is a kind of function that helps to concatenate multiple items, and for that you can use the following cat. So cat, and then at the end you might set this one here, and run it. So you got it. Now it concatenates the board data types together. So this is one way, and there might be another way as well. And for that, let's look at our earlier examples. So we got something like the temperatures. You remember my maybe this part here, and we ran in this way. This you see it works. So then print paste, and I just take this part out, and then I try to run it in the same way, and you see it works fine. Completely okay. So cat would work, and this paste would also work for our case very well. So we got actually these parts, and we can move forward in setting variables, and a few things we also realized. So how to store values. Now if you want to set or save a value in a variable, the way how you do it is this here. So the assignment operator is a set of less than and a hyphen, you see that, but no space between. So no space between. Using R in calculator mode gets old pretty fast. So you will want to define variables and save values in them. This reduces typing, saves time, and clarifies your work. There is no need to declare explicitly create variables in R. Just assign a value to the name, and R will create the variable. When you define a variable at the command prompt like this, I can show you in RStudio as well. So let's get rid of this here, and let's make that. So x is 3, this is it, and we can run the single line, and then we can run also print x to it. So when you define a variable in this way, what happens is the following. The variable is held in your workspace. You can see it here as well in the environment. Let's try to move it, and you see it here. Okay, so this data I got before. So what I could do is indeed I could get rid of it. So here is it. And now nothing is indeed there. So I need to create the value again. You see that? And whether this is global or not, we will see it later. So this is not a global variable. I can say it now, but we will talk about it later again. Now, the workspace is held in the computer's main memory, but can be saved to the disk. So make sure that in any case, if you'd like to continue your work, it's better you save your work. So you see it now, it's untitled, but if I'd like to continue my work, and it's easy to save as and then start from there. Still, if you just call the X and you see save workspace image, then don't save, and I can start again. And normally we don't have the problem to start from here, but again, as I said, you see now X is not created, drinks is created. Now drinks actually I don't need anymore. That was from the other book, but what I need to do is to create the X. So I need to run it, and now I have the value saved. Okay, the variable definition remains in the backspace until you remove it. You saw how I removed it. And then R is a dynamically typed language. We can see it also here. That means the variable's data type can be changed, and it's variable. So we can set X to be numeric, just as shown before, then turn around and immediately override that with a vector of character strings, and R will not complain because we just overwrite it. All right, now let's see the next one. So here it is. We created X with the value assigned to X 3, and now we can create, or we can update it by as vector with the following words in it, or character strings, and you see now X has been changed. That forces the assignment to be global variables. So X double less than is now 3, and it forces the X to become a global variable. We will also reveal that R also supports 2 other forms of assignment systems or statements. A single equals sign, so let's say foo is equal 15. You see that here, and 5 to fum, and you see fum is the name. Now we don't recommend it, as you know. I also don't recommend it. I learned in this way, creating or setting the variable itself. The equals sign assignment is easily confused with the test for equality, and the test for equality would be like foo is 15, so, and it's going to be true, as you see, because this is about the testing for getting the Boolean values. Now the next one is about listing variables. Here you want to know what variables and functions are defined in your workspace, and you can use the ls function, which is the list. Now be careful if you run that. You need to use it in this way. You see that? And then if you just run it in this way, then it will simply describe what the R is doing. So the function itself, the ls is doing the function itself. If you use, however, ls string, so let's see what you get then. And don't forget the parentheses at the end all the time. So you see now there are environment namespace and foo and fum and so forth and so forth. So let's get back again. Let's create our example here for this ls stuff. X will have the value 10, 50 will be assigned to y, to z we assign a vector, 3 blind mice, and f function and p sqr t p times 1 minus p and divided by n. Okay, well, if the last one, I'm not sure if the last one would work. Seems to be okay. Then let's try to list it. Now we got that. Okay, so we got f. These two actually we can get rid of. Let's get rid of them. And let's just create these. And then now I can list them. So f, x, y, and z, just as the book has them. Now, notice that ls returns a vector of character strings in which each string is the name of one variable or function. When your workspace is empty, ls returns an empty vector which produces something like this when I get rid of everything. So ls character 0, you see that. Great. Now, that's our client way of saying that ls returned a 0 length vector of strings. That is, it returned an empty vector because nothing is defined in your workspace. If you want more than just a list of names, you can try the ls-str. This will also tell you something about each variable. You see that here, so function np, then numerical value 10, numerical value 50, then also here characters 1 to 3 and 3 blind mice are the list elements in that way, or vector element. The function is called ls.str because it is both listing your variables and applying the string function to them showing their structure. Ordinarily, ls doesn't return any name that begins with a dot. Such names are considered hidden, like hidden files, right? And are not normally of interest to normal average users. I've already mentioned that the environment pane in RStudio also hides objects with names that begins with dot. The next what we will talk about is deleting variables. So let's come to the next point, deleting variables. That means you want to remove unnecessary variables or functions from your workspace, or to erase its contents completely. Now, you have seen already one way where I actually used this brush to get rid of them. But now you can also see how to use the rm function, so rm, right? And we have created a few, so let's take x into rm. And let's run it. And you see now x is out. We can also get rid of the f, so rm, and now I come here, and all I do is just the arrow up, and now I take f here, and f is also gone. It was a function, we got rid of the function as well. Great. Now there is another one. Your workspace can get cluttered quickly. The rm function removes permanently one or more objects from the workspace. So x, let's create x again, this time 2 times pi, and then we got that value, and we get remove x, and we can get remove x, y, z in one single time as well. So let's run 2 of them, and you see now you don't have the other variables as well. In that way, here, let's make them again. And then you can erase your entire workspace at once. The rm function has a list argument. So let's use the list this time again, and we see f, x, y, and z. And what we can do is remove and list, and the list is the ls. And in this way, what we do is the following. We get these ls to and combine with a remove function, and this will delete everything as you see now. Alternatively, you can also click the broom, so brush broom I mentioned before, at the top of the environment pane in RStudio. Now, never put this here into a code you share with others, such as a library function or sample code sent to a mailing list or Stack Overflow. Deleting the variables in someone else's workspace is worse than rude and will make you extremely unpopular among people. So use it only for yourself, don't use it otherwise. So I also will just out-comment it. Now, creating a vector. Finally, we come to the vectors. Use the C. So here you see that. Oops, C to create a vector. 1, 1, 2, 3, 5, 8, 13, 21. and let's run it, and we have now a vector, but this vector is not saved yet. And we can continue in that other way as well. So see, the next one is 1 times pi, then 2 times pi, then 3 times pi, and 4 times pi, and so forth and so forth. So I actually don't need these spaces in between, and we got these values. Same goes for a vector of strings, and we can also create a vector of Boolean values, so true, true, false, false, etc., etc. Okay, now if the arguments to C parentheses are themselves vectors, it flattens them and combines them into one single vector. So now let's create v1, vector 1, c, 1, 2, and 3, and v3, c, a, b, and c. And create the vector v1 and v3. Let's run only these 3 lines. You see we actually merged the 2 vectors into one single vector. So here we tried to create a vector from both numbers and strings, converted all the numbers to strings before creating the vector, thereby making the data elements compatible. So compatible. Note that R does this without warning or complaining to you. Okay, now technically speaking, 2 data elements can coexist in a vector only if they have the same mode. So mode pi, numeric, you see, and mode foo is this time character, but if you put them together, so C and pi without the quote mark, actually I do it in this way so that you see it better, and foo, and then mode C 3.1415 and foo. I see that, and now you see it's a character. So C is a general operator, which means that it works with many data types and not just vectors. However, it might not do exactly what you expect. So check its behavior before applying it to other data types and objects. The next part, what we do is about this we have done, and computing basic statistics is the next part which we are supposed to do. Okay, so let's take this example here, and then once we finish, this is completely over. So here we go. You use one of the following functions: mean, median, standard deviation, variance, and correlation or covariance. And when you first use R, you might open the documentation and begin searching for materials entitled Procedures for Calculating Standard Deviation. It seems that such an important topic would likely require a whole chapter. Well, it's not that complicated, as our book also says. Standard deviation and other basic statistics are calculated very simply. Ordinarily, the function argument is a vector of numbers, and the function returns the calculated statistic. So you see it here, and also we run it in that way. I create the same vector, just as in a book we have it. But before that, I would like to separate it from the other parts. And here we go. We create dam mean and x. Let's run both. And we could remove v1, v3. I hope it works in this way. Right, great. And then we can continue from here. So the median we can calculate as well. Let's run the median. The standard deviation we can immediately run as well, and the variance we can run as well without any problem. Great. Now, what are these values actually? Again, the standard deviation, as from the Investopedia, you can see here, is a statistic that measures the dispersion of a dataset relative to its mean, and it's calculated as the square root of the variance. Now, what is a variance then? So the term variance refers to the statistical measurement of the spread between numbers in data set. More specifically, variance actually measures how far each number is from the mean in the data set, and thus from every other number in the set. So how far are these numbers from each other? That's the variance. That's why we get a high number. And from that, if we take the square root, we get the standard deviation. Also, let's take another look here. The correlation and the covariance. The correlation is, again, from the Investopedia and on the internet. You see that here as well. Is a statistic that measures the degree to which two variables move in relation to each other. It can be a negative correlation, then they move completely differently from each other, or it can be even up to one, so they move together. And then covariance. Now, oppositely, if they move completely oppositely, of course, correlation, then they move in this way. That means that it's -1, right? Now, covariance is a statistical tool that is used to determine the relationship between the movements of two random variables. Great. The correlation and the covariance functions can calculate the correlation and covariance respectively between two vectors. Let's get these two vectors already. So I created X and I created now a Y. So correlation of between X and Y, we look at that one. Correlation between X and Y, sorry. So they are nearly moving together, right? And a covariance, again, random, right? X and Y, not Z and Y, X and Y is 11.49. So once again, the covariance is a statistical tool that is used to determine the relationship between the movements of two random variables. All these functions are very picky about the values if they are not existent. So NA. Even one NA value in the vector argument causes any of these functions to return an NA, or even hold all together with a cryptic error. So we got X now updated. C 0 1 1 2 3 and an A. Let's try to run it, and let's get our mean X, and you see we get an NA, and the standard deviation, because we got one single NA, we also get the standard deviation run, and we get an NA. Well, it's annoying when R is that cautious, but it's appropriate. You must think very carefully about the situation. Doesn't NA in your data invalidate the statistics? Right? If yes, then R is doing actually the right thing. If not, you can override this behavior by setting the NARM true, which has R ignore to ignore actually these NA values. So let's do that part as well. Okay, so we got X and SD, and now we set that, so X and A are and it's true, so it's overwritten. We got rid of it, and now we can only think about these values as the basics for, or the fundament for our standard deviation. Now, in older versions of our mean and standard deviation were smart about data frames. They understood that each column of the data frame is a different variable, so they calculated the statistics for each column individually. This is no longer the case. And in order to apply the standard deviation and the mean functions to each column of the data frame, we now need to use a helper function. And this is the tidyverse family of helper functions for this sort of thing in the Pure package. So how do we get that done? Well, let's see if the Pure is here. It's here. So you see it, library Pure is what we do, and now it's already done. As with other tidyverse packages, this gets loaded when you run library tidyverse. So now we can get rid of it, and let's do library and tidyverse. And let's see what is been doing. And you see Pure is actually started. And then we could get here data cars. The example, so this is now, you see this is what we have, so the distribution and speed. Okay, and let's get back to our code. So this is a data frame, obviously. Notice in this example that mean and standard deviation each return two values. So map dbl calls mean. Here we go. And we can do more than that. Standard deviation. Here we go with the next one, and then the median. And these are the values. Now, one for each column defined by the data frame. Technically, they return a two-element vector whose name's attribute is taken from the column of the data frame. The variance function understands data frames without the help mapping, so you can do it simply as you see here, var and cos. And likewise, if X is either a data frame or a matrix, then correlation X returns the correlation matrix. Okay, here we have nothing but cos, right? Yeah, here we go. You see that it's perfectly one, right? And then covariance X returns the covariance matrix. So covariance cos, actually. And this is the matrix for that. Great. And then we finished with the major task for now. So what we have done is the following. Wow, that's great, awesome. So now we know how to use the print function very well. We know now what is cat. We know now that we can use the print function with the paste if we would like to use more than one data type in a basically to display that. We also know how to create global variable. We know that we can use the equal sign for creating the variable, but please don't do that part. We also know, and we know how to create vectors. We also know how to what happens if we create from two vectors another vector. You remember that? And then you see that in the case we create a vector from two different vector data types, we get actually the higher the data type, so we get the character. So this value is going to be that, it becomes a character because we use here a string. So both of them are going to become strings. Then we also learned about mean, median, standard deviation, variance, covariance, and correlation. So those basic statistical elements or units we learned about, and then how to use them with the helper function, what we talked about. So this mapdbl is supporting it. Other than that, in the case of variance, correlation, and covariance, we don't need to use mapdbl. However, let me also check if we could use it. Okay, so possibly, if it's necessary, could we use it? So it's a good question, and therefore let's also reply this question for now. And you see, yes, definitely we could use it. That's it for now. I would like to say thank you very much for your attention for the beginner part in our about the programming way of our. So have a good time. Try it out by yourself, and see you the next time. Bye.